Welcome back to our channel, and it's me again, Zoe Pelayo, and today I will show you how to solve for limits. So let's go. Hi guys, before I show you how to solve for limits, let's know something about limits. So what is limits? Limits is defined using the notation on the left, where f of x is a function of x and c is an element of real numbers. We can read this as limit of f of x as x approaches to c is equals to L, or limits. So this is our equation. We can easily know our limits because of its function, as limits of 2x plus 1 as x approaches to 2. We will start on the left hand side first. Note, we always have two hand side, which is left and right hand side. So in the function, we need to find the value of c, which is 2. We find 1.99, 1.99, and 1.9. The next is we will substitute the value of x in our equation. So the value of 1.999 will become 4.998. The value of 1.99 will become 4.98, and the 1.9 will become 4.8. So that's our left hand side. Now let's find now the value of the right hand side. On the right hand side, we need to find the greater than our x value, which is 2. So we need to find the number that is greater than 2, and we will get 2.001, 2.01, and 2.1. After that, we will use the same rule that we use on the left hand side. So the 2.001 will become 5.002. The 2.01 will become 5.02. And 2.1 will become 5.2. So that's the value that we will get if we substitute the value of x. So let's see our answer. We can say that the limit of 2x plus 1 as x approaches to 2 is equals to 5. So we have one-sided limit. We have left hand side and right hand side. In the left hand side, we have limit of 2x plus 1 is equals to 5 as x approaches to 2 negative. And right hand side, as limit approaches to 2x plus 1 is equals to 5 as x approaches to 2 positive. So now we need to graph it, the value that we get on our table. This is the table, and we have the left and right hand side, which is this is the left and this is the right. We can read our notation as the limit of f of x as x approaches to c is equals to our limits. The last one is we can estimate the value of limits by using our table of values, which is what we do earlier. We also need our left and right hand side. Then if the value that we get is not the same, we will consider the limit as undefined, because we always need to get the same value. If we don't get the same value, it will become undefined. So that's it, guys. I hope you like the video, and I hope to see you soon on the next one. See ya.
Good day. I am Karen Joy Dumabilangan of CHS2, and now we are going to talk about derivative by definition. And the formula that we need to use is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And now, I will give an example. F of x equal 5x minus 4. First, we are going to evaluate the function with x plus h and x. Minus 5 5x minus 4 all over h. After that, we are going to distribute the constant term and perform necessary operation. Five x plus 5h minus 4 minus 5x plus 4 all over h. Then, add all the constant term. 5x plus negative 5x equal to 0. Negative 4 plus 4 equal to 0. Copy 5x over x, 5h over h, cancel the common factor, and the answer is 5. The derivative of 5x minus 4 is equal to 5. And now, I will give an example of derivative by definition of limit. And this is also the formula. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, let's solve this. First, we need to substitute the value of x to the equation. After that, we need to evaluate the function with negative 1 plus h and negative 1. Then, expand the binomial and perform necessary operation. H squared minus 2h plus 1 minus 4. Negative 1 raised to 2 is negative 1. Minus 3, negative 3. All over h. And now, add all the constant term. One minus 4 is negative 3. Minus negative 3 is equal to 0. All over h. Then after that, factor out the common factor of these two terms. Cancel the common factor. And the answer is let's simplify. And the answer is f prime of negative 1 is equal to negative 2.
I am Alana Isabel Ikamlas from CHS2. So now I am going to discuss about the basic rules of derivatives. So let's start. The first rule that I am going to discuss is the constant rule. So this is the formula of the constant rule. D all over dx c equals to 0. So the example for constant rule is 3 dx equals to 0. 18 dx equals to 0. The derivative of any constant is equal to 0. So for example, this one, 3 dx equals to 0. It is always equivalent to 0 because the number is always constant. So the next rule is the identity rule. The examples for identity rule are RDR equals to 1, x dx equals to 1. The derivative of any identity function is equal to 1. The third rule is the constant multiple. So this is the formula for the constant multiple. The example for the constant multiple is 2x cubed. The given is 2x cubed. Then the procedure goes like this. You will first copy the exponent and will place it in the front. So it will become 3x. Next, for you to find out the exponent of x, you will minus 3 minus 1. So the exponent will become 2. Which means that it is 3x squared. Afterwards, 2 is given. So you need to multiply 2 and 3x squared. So, like this. 2 times 3 is 6. So, just copy the x squared. So, this is the final answer. The derivative of a function that has a factor c is equal to derivative of the function multiplied by c. So, the fourth rule is the power rule. So, this is the formula of the power rule. So, the derivative of a variable raised to n is equal to n multiplied by the variable raised to n minus 1. So, I have here two examples for the power rule. First is x to the fourth. So, the first things that we need to do is we need to get the exponent of x and copy in front of the x. So, it becomes 4x. For us to get the exponent of x, we need to minus the 4 to 1. So, it becomes 3. So, this is the final answer for the example number 1. The second example is x to the fourth. So, same as number 1, we need to copy the exponent and place it at the front of x. So it becomes negative 4x. So for us to get the exponent of x, we need to minus the 4x to 1. So it becomes negative 5. So this is the final answer for the example number 2. The last rule is the addition and subtraction rule. This is a formula of the addition and subtraction rule. The derivative of a multiple functions or terms being added or subtracted together is equal to the sum or difference of the derivative of the equation or terms. So I have here one example for the addition and subtraction rule. My example is x squared plus 5x minus 3. The first thing that we need to do is solve for the derivative of each term using the power rule. So the exponent of x squared is 2. So we need to copy it and put it at the front of x. So it becomes 2x plus 5 because the exponent of x is equals to 1. So we don't need to put it at the side of the x. So this is the final answer for the addition and subtraction rule.
Hi guys, I just want to say I'm sorry in advance because of the quality and the voice in the video because I was sick while doing it, so I'm really sorry about it. Let's get into the video. In this video, we're gonna talking about additional rule of derivatives. Here you will see three additional rule of derivative: product rule, quotient rule, and chain rule. First, let's go to product rule. Product rule is let f and g be a function that is differentiable at c, and the formula of the product rule is fx times gx dx is equal to fx times g prime x plus gx times f prime x. Now, let's go to example. Is equal to x plus 1 and gx is equal to 4x minus 5, or its derivative is 4, while f prime is 0 because we're gonna use the constant rule on them both of them. Then we're gonna use next is product rule as f times g prime x is equal to x plus 1 times 4 plus 4x minus 5 times 0, and the answer is 4x plus 4. Now let's go to the quotient rule. Quotient rule is similar to the product rule, but it is a function, and the only difference between them is that the negative side and the function over is raised to 2. Now let's go to the example of the quotient rule. First you want to do here is let fx and gx be x squared minus 2x plus 1 and gx is equal to 2x plus 9. Then after you do that, you're just gonna need to find the derivatives of those two. So f prime x is equal to 2x minus 2 and g prime x is equal to 2. After you do that, you use the formula. Then you're just gonna multiply the 2x plus 9 to 2x minus 2 minus x squared minus 2x plus 1 times 2 all over open parenthesis 2x plus 9 close parenthesis square. After you do this, you just gonna need to combine them like terms. After you combine them like terms, that is the final answer. Okay, chain rule. Chain rule is normally being used to definition composed set of functions. Example, x squared minus 2x raised to 2, remote parenthesis and raised to 2. Then x squared, what you're gonna do here is find the derivative and the substitute. So x squared minus 2x is equal to 2x, while its substitute is u raised to 2 du, still du, is equal to 2u du. Then after you find the derivatives and the substitute, you just combine them like the product rule. You just need to do the product rule, but there's no plus. It's just what, fx times g prime. That's all you need to do. Then after you do that, you just multiply the g to the constant. You can't multiply the f to the constant.